Today, we're going to tackle one of my all-time favorite logic puzzles. It's a real classic, a true test of creative thinking and teamwork. It's the Prisoner's Hat Riddle.
So, imagine this. You and 9 other people have been abducted by aliens. And yeah, they're thinking of having you for dinner. But there's a catch. Their society has this one rule. They're not allowed to eat any species that's highly logical and good at cooperating. So, to figure out if you're on or off the menu, they've set up a little test.
Here's the basic setup. There are 10 of you. They're going to put either a black or a white hat on each of your heads. To survive, at least 9 of you have to correctly guess the color of your own hat. You're allowed one, and only one, wrong answer.
Sounds pretty much impossible, right? Well, like any good riddle, it all comes down to the details. Let's walk through the specific rules the aliens have laid out. Okay, so first they put all of you in a single file line, everyone facing forward. This means the person at the very back of the line can see the hats of all 9 people in front of them. The next person sees 8, and so on, all the way down to the poor person at the front who can't see any hats at all. Then, starting with the person at the back, you have to call out your guess, black or white. That's it. You can't change your tone of voice, you can't cough, you can't use any other signals, just one word. Get it wrong and, well, you know. Now here's the good news. The aliens give you 5 minutes before the test begins to talk amongst yourselves and come up with a strategy. So what do? Is there a plan that can guarantee that at least 9 of you get it right, no matter what the hat combination is? Seriously, now's a great time to pause and really think about it.
All right, you ready? The solution is incredibly clever, and it all hinges on using that one word, black or white, as more than just a guess. It has to become a piece of information, a code. And the secret to that code is a concept you learned in grade school, parity. It's just a fancy word for whether a number is odd or even. The solution has nothing to do with the total number of hats. It's all about whether the number of black hats is odd or even. Here is the brilliant code you all agree on. The very first person to speak, the one at the back of the line, isn't really guessing their own hat color. They're communicating the parity of the black hats they see. So if they look ahead and count an odd number of black hats, they will say black. If they see an even number of black hats, they'll say white. That one word sets the stage for everyone else. Okay, I know, it sounds a little abstract, but does it actually work? Let's do a walkthrough with a real example to see this chain of logic in action. All right, the hats are on, the test begins. Let's focus on prisoner number 10, the guy at the very back. He looks forward at the 9 people in front of him, and he counts 3 black hats. Okay, so he sees 3 black hats. 3 is an odd number. So what does he do? He follows the plan. He calls out, black. Now, everyone in the line has just received a critical piece of information. The number of black hats among the first 9 prisoners is odd. His own guess is a coin flip, a 50-50 shot, but that's okay. He is the one allowable mistake. His job was to pass the code. Now it's prisoner number 9's turn. She heard black, so she knows the initial count was odd. She looks forward at the 8 people ahead of her, and she also sees 3 black hats. Well, 3 is already an odd number, so for the original count to have been odd, her own hat can't be black. It has to be white. She confidently says white, and she is 100% correct. Perfect. Now let's go to prisoner number 8. He also heard that first call, black, so he's also expecting an odd total. But when he looks forward, he only sees 2 black hats. That's an even number. So he thinks, wait a minute, the total should be odd, but I only see an even number. The only way that makes sense is if my hat is black. He says black, and guess what? He's also right. And you can see how this just keeps going, like a set of dominoes. Each prisoner listens to the original code word, counts the black hats they see, and does the math. The difference between what they expect to see and what they actually see reveals their own hat color with total certainty. So you see, when you pull it all together, what you have is a strategy that isn't about luck at all. It's about logic, and it is completely 100% foolproof. 9, that's the magic number. This strategy absolutely guarantees that 9 of the 10 prisoners will guess their hat color correctly, every single time. And the whole thing works because of one person's sacrifice. That first prisoner at the back has a 50% chance of being wrong, yes, but their guess isn't a guess at all.
It's the key that unlocks the puzzle for everyone else, turning their impossible situation into a simple problem of deduction.
So why is this so unbeatable? It's simple. The first prisoner sets a baseline truth. The number of black hats is either odd or even. From that point on, every other prisoner is just doing a little mental bookkeeping. They listen, they count, and they compare what they see to what they know should be there. The discrepancy is always the color of their own hat. It's a beautiful, elegant, self-correcting system.
At the end of the day, this riddle is about so much more than hats. It's a powerful lesson in how a seemingly impossible problem can be solved with a little bit of cooperation and a single, cleverly shared piece of information. It really makes you think, doesn't it? What other huge problems could we solve if we just figured out the right, simple piece of information to share?